All right, welcome. This is the AP Physics Momentum Test Review. Here I'm going to go over the multiple choice. This is the last part of the multiple choice, 25 through 35. Okay, here it asks us to find the mass of M. Okay, so to find the mass of M, you could approach this from a conservation of momentum question. So here, please understand the P here is 0, the momentum here. So we have M, sorry, it's little m. The little m vi is going to be equal to little m vf plus big M big V. Okay, so you want to solve for the mass of M. So it's M vi subtract M V final divided by V. Okay, that is the big mass. To get, its initial velocity. All right, you have its final velocity and you have its initial velocity. All right, so here you could work it out. Right? Do we have moving fissureless staff with a graph? That's its initial mix of study. The second block is originally at rest after collision. The 4.5 kilograms reconciles at a good. What is the mass of Posh? Right, so here you could actually compute it out. You will get 7.7 kilograms, okay, for its mass. All right. If you're wondering how to get its velocity, because you can't really divide the final, because you have the initial velocity, then you have the final velocity, but you don't have this velocity. Where are you getting this velocity? To get this velocity, to get the V, the big V that's coming out, because you don't have the big V here, you're going to use the energy. So energy final minus is equal to be your energy initial. So it's 1/2 m little m v squared, that's vi. This became 0, so this is 0, is equal to 1/2 m v squared again, plus 1/2 m big M v squared. This is the way you can solve for it. Okay, because you have its initial velocity and a final velocity here. Okay, so you could solve for V. Then you plug it in, it's going to be equal to 7.7. Okay, but that's sort of the algebra for it. Right, 26. This is a bullet. This is a collision problem between the bullet and the block. I'm just going to give you the answer because working through it's going to take a long time. But understand that when it hits that to find the velocity, you have to do changing of kinetic energy. So E final is going to be equal to E initial. Okay, your here I could just flip it for you. E initial is going to be equal to your E final. Right, so it was originally, when the block hits it, it is 1/2. So this is the bullet mass plus the block mass. Okay, and it's going to have a velocity squared. This is going to be equal to there is no more 1/2. This 1/2 thing goes away. Okay, because it's all going to go swinging up, so it's all going to become a mgh, but the m is bullet mass plus block mass. This is m, this is the total mass, so it's going to be times g times height, which you have the height here is 0.40. Okay, here you can solve for v. All right, so that's how you would do it. Okay, 27. So here there are two scenarios you're gonna hit. Okay, which of these situations will result in the greatest impact? So the greater impact force on your car. Okay, so when you hit when the two, because you're driving 30 miles and crash heads onto an identical car at going 30 miles an hour. In the second one, you're driving 30 miles per hour and crashing into a stationary block, right? So the momentum is going to change, okay? But the force will remain the same because it is B due to Newton's third law, all right? So your force of your car on car is the same thing as the force of your car on wall, right? It's going to be pushed F forward, so it's going to get hit by F as well. Here it's the same thing. F is on the wall, and the wall is going to push back with an F. Okay, so the force will be the same in both cases. During World War I, the German used Big Bertha to hurl shells into Paris 30 miles away. This has a very large barrel, so I can draw it to you. It has a big barrel where the artillery gets shot up, right? Okay. Why is the reason to increase the barrel size? To increase the force exerted? No, force is equal to mass times acceleration. There is no length involved here. To reduce the force exerted on the bullet due to the expanding gas of the gunpowder. To reduce the force, again, has nothing to do with force. To exert a larger force on the shell. No, because this doesn't do it doesn't do that. To exert a larger force on the shell. No. To reduce friction loss. No, you were actually increasing friction though. Okay, because there's more barrel, so you are increasing friction. You are increasing force of friction, so this is wrong. This is also wrong. So the last one left, to allow the force of the expanding gas from the gunpowder to act for a longer time. So again, the formula is force times delta T, and this is going to be your impact force, your impact, or you could call this your change in momentum, right? But we know that you want a large time. Okay, that's the reason why. So the answer would be E. 29. Okay, two friends are in a canoe. Yeah, here's a canoe. Here is the river. One friend throws the ball to the other friend that's on the other side of the canoe. Okay. Um, the canoe is what after the ball is thrown? It's stationary. Why? Because originally at the start it is M plus big M, right? This is M plus big M times P. In the end, it's still M plus M time. Sorry, V. V. Okay. The momentum is conservative. The masses are the same, so the velocity has to be same. In this case, the velocity at the start was 0 because the momentum was 0. It was at rest. So at the end, it's also going to be at rest because its mass is the same. No mass left the boat. That's why it's still stationary. It is only when the mass leaves the boat that the canoe will start moving. Let's look at 30 here. A small car meshes with a large truck in a head-like litter. Which of the following statements concerning the momentum during the collisions are true? The momentum of the truck is conservative. So this wouldn't make sense, right? Because watch, the car is going to hit the truck. Okay? Right? So the momentum of the truck is not conservative because this is a total system. Okay? So this is wrong. The momentum of the car is conservative. That is wrong. So the car and the must undergo the same change in speed. Wrong. They cannot go. They cannot go the same change of speed because this is going to. Let's say its velocity initial was like 10. Its velocity final is going to be like greater than 10. Why? because the momentum of the truck is going to be given to the car increasing its velocity. Okay, here the truck is going to be differently. So here that would be off. The momentum of the car and the trucks are each conservative. Not quite. The momentum of the car truck system is conservative. This would be correct. The momentum of the car truck system, not the momentum of the car and truck. It is when you treat them together as a system, okay, that the momentum is conserved for this scenario. But the momentum of each separate is not conserved. That is correct. Because again, this is going to go at a different velocity. This is going to go at a different velocity. That's why their momentums for each of them are going to be different. Let's look at the next ones here. 31. You're standing on against a skateboard. Your friend throws it to you. How do you remain? How do you you want to remain the same speed as the original thrown? So you have momentum initial is going to be equal to the momentum final. If you catch the ball, it would be mv is going to be equal to m plus m of the ball times velocity. So this is wrong. Your final speed on the skateboard will be the same regard whether you catch the ball or deflect it. Well, that is wrong because again, it's completely different. If this is higher, this is going to be lower. If this is lower, this is going to be higher. Your final speed with the skateboard will decrease either way. It would not decrease either way. Okay, so the best option is to deflect the ball back. You want to deflect it with the time is equal. The time is when the limit of x approaches 0. Okay, so you want to do that. Okay, for x. Right, you want it as close as possible to 0. 31. Did I skip? Oh, that is 31, 32. In this scenario, you're going to look for which of the following statements about the bounces are true. A elastic rubber ball is dropping from a height and hits the floor with a downward speed of v. Here's the ball, drop from a certain height, it hits it. It's so elastic that the ball bounced back with the same v. So this is v5. V equals to 5, so the ball bounces back at v also 5. So part of this is the ground. Okay, which of the following statement is true about the bounce bar back? The ball momentum was conserved during the bounce. The momentum conserved was during from the bounce. Not quite. The ball had the same momentum just before and just after the bounce. The magnitude of the ball momentum was the same just before and after. Well, this one would be correct. It's worded a little bit differently. The ball was conserved during the bounce. This is before and after. This was the same just before and just after the bounce. So read the type of question, okay? And this is the magnitude. The momentum is not the same because watch. If I treat anything going up and right positive, this is completely different. The P here, let's say the mass here was like 2. The momentum here would be 10. What it would be the momentum here? The velocity is in its opposite direction. Mass is still equals to 2. This would be negative 10. It goes from 10 to negative 10. Right? The change in momentum would be just 20. Completely different. Okay? So the answer would be C. 3. Here are 3 cars. Car X is more massive than car Y, which is more massive than car V. The net acceleration force right here, the net acceleration force okay is identical. The time here is going to be 10 seconds. They all have the same momentum. Please understand that it is F times delta T, which is going to be equal to the impulse. The force here is what? They're identical. So they're the same force and the same time If they all have the same force and the same time, they all have the same momentum. Okay? Why? Because they have the same force, same net force, and they also have the same time that occurs that they're applying that force. Okay? 34. A car is moving 15.6 meters, suddenly collide with a stationary car of mass that what the two vehicles together combined, what is the velocity after? So mv plus mv initial is going to be equal to m plus mv. Please understand that the what it was with a stationary car, so this one goes bye bye. Okay, so now what you can do is you can just divide this by m plus m. They could divide this by m plus m. Right? So what do we have here? We have the first one, which is 15.6 times that. That's going to be divided by the 1200 plus 1500 close. That's going to be equal to its velocity. Okay, doing that work, the answer should be 6.9. 35, which is the last one. This is what happened if 5 kilogram ball collides inelastically head on with a 10 kilogram ball. Well, which is stationary? Which of the following statement is true? Right, so here's the 5, here's the bigger one, 10 kilograms. They collide, right? So let's say the velocity here was just 2. They collide. The velocity here was equal to 0. Okay. I know I spelled that wrong. Okay, it's supposed to be velocity. Okay, velocity. All right. So if you hit this, this becomes 10, right, kg times meters per second squared. In the end, this also has to be the same. This also has to be 10 kg times meters per second squared. All right. So how does that work? So the magnitude of the change of momentum of the 5 kilogram ball is equal to the 100. It should be the 100 kg. It shouldn't be 109. That would be wrong. The magnitude of the change of velocity of the 5 kilogram is less than no. You would say that the wouldn't be the change in the velocity. That's correct. Of the 5 kilogram experience is equal. No, that would be wrong. The velocity would be less. The magnitude of the change in the velocity experience is greater. No, that is wrong. The velocity is actually less. Okay? Right? So, wait, hold on. No, it is more because the object, this is a lighter object, so it is going to have a greater force. Okay? Because the lighter one has to move more. So, the answer would be D. The velocity of the velocity of the 5 kilogram is going to be greater than. Okay, why? Because it's a smaller object, so it's going to have more velocity. Right. So there you go. That was 35.